Good morning, everyone. I would like to show you a little bit about my metac programming language and how we do a novel feature called the eject expression. Not eject statement. Let me show you a little, nah, not that, a little example of how this might look. Let's see, yeah, why not this one? So essentially, when we have like a function, which by the way, uh, auto makes this implicitly a template, so this is like t enum value, right? And so yeah, when we hit that, it like here, it will instantiate this with the type E, which is this enum over here. And on instantiation time, this add run block will be executed. It will grab the type using compiler get type, and compiler get type gets um, the actual type. Because if you used a type of enum, well, actually, type of enum could work, but uh, I'm not, I'm not 100% sure. So for now, I'm gonna use this. It then, um, this run block executes. It gets all the enum members, which is an which is an actual struct. Let us see, enum members t. Um, it gets that, then it does a for loop over it, and we actually don't use the latest and greatest eject syntax here. So let me quickly fix that. Eject basically takes everything that's in here. It substitutes. It substitutes what is in here. This dollar thing gets substituted, and then this hash symbol in front of the dollar means to stringify what's substituted, which takes the identifier of the current member. So that's how it is. And that should actually work once the language is good enough to do that. However, right now what we want to do is to actually finish this eject statement so that we can parse it properly. So in order to do that, we have a little helper. We have a REPL here, and I wonder whether I can force this OBS to go to the tray, but I'm gonna worry about that later. So we want a statement. Let's first do an empty eject statement. This should work, but apparently it doesn't. And the reason why it doesn't is because it cannot get the location. So What this tells me is that we set this breakpoint here incorrectly. So let me remove it and put it at a edit breakpoint, ignore breakpoint, remove breakpoint. Let's put a breakpoint at a different place. Here. Alright. So let's now recompile this. And let's first check if we are able to do this peeking thing properly. Let's do statement and let's do an eject without a following brace. That would do the pass error. And it does correctly say pass arrow 1 1. Let's say eject has to be followed followed by there we go. And then let's now do a thing where this will work. But we will error because they're imbalanced. Let's eject that. So now we go through this. We should not have. Oh, interesting. So now I wonder what peak token is. Peak token points to eject. Oh, that's because we yeah. We haven't advanced our thing yet. Okay. So let's actually put this into peak n. And after that, start at eject this. We enforce that it starts with an open brace. Let's now skip over that. Skip over. And we do peak n plus plus. Because we have now essentially to the return statement. We haven't hit this branch, we assume, otherwise we would have returned an error statement, which I'm not going to do for now. Then we skip over the open brace and we will be good. The depth starts at 1 because we have skipped over that. So now let's continue. Let's continue. Let me restart this and do eject that. Now this should go into a situation where we don't hit depth 0. And the token we have is already an invalid token, and I wonder why that is. I think it has to do with the value of peak n at this point. Um, peak n is 3. And let's see. Give me tokens at 3. So the token has one valid token, which is eject. After that comes nothing. After that comes garbage. I wonder why. Oh, it's because I'm quite sure it has to be like this. Yeah, 0 is eject, first is L price, third is invalid. So this has to go in an else branch, otherwise we can't even properly look into the tokens, right? So let's go now and let's do a thing where we do eject that. Well, we are in expression mode, so yeah, the token eject would be unexpected. Let's switch to statement mode, eject that. Let's now check our peak token. Peak token is 0. We have to yeah, thing is this works. The first peak token works. We do an assignment in here that grabs the last peak token, which is not what we want. So what I would want to do is, if this loop terminated because we hit a 0 token, what I want is if not peak token, I want you to assign peak token to the last token that is presumably still there, but which would be peak n minus 1. And that will then give us a valid token which we can complain with in here. Which is then peak token, I would say. Okay. Let's now do the unbalanced parenthesis version of the peak token fail. Now let's check if we have a correct peak token. We have a pointer that's non-zero at least. We now grab the tokens, grab the location, and we have an unexpected thing at our right. Unexpected EOF while parsing eject block. That is what we want. So now I will put a proper eject block in. Eject done that. Let's continue parsing. And we get an assert, but we get an assert in print statement because print statement doesn't handle statement eject, and hashing doesn't handle statement eject either. So what we are going to do is so hashing an eject statement will be tricky. Hashing it properly will be tricky because we would have to compute a token hash, but we can definitely do we can put a case in here for this thing to not die. So let me, actually I want to put it close to run, to the statement run. Statement run, there we go. Yeah, in between run and while, because that's where we have put it in the parser. It is almost like this, except that so the run we have, what was it again? It is statement eject, right? Yeah. There we go. The run, it's eject. Eject, and there we do eject. Then we do like print eject. Oh, we could even do the print keyword one, why not? Print keyword. Keyword eject. Then we print the space, and that's that. For now, print eject content. Then we do the print car for the braces. I don't know if I have a print toc. I may have a print token. I have a print token. Brace. Well, if I have a print token, then token brace. Then the whole thing is different. We could actually loop over at least the token types, and and then print the token types. We can do that, and if that's the case that we have that, then yeah. I'm not gonna change the rest of the printer just in case this doesn't work correctly, but yeah, this looks better. Eject. We can do this now. This should result in a valid eject statement, and the statement prints out that, but of course we haven't we haven't done it properly. So if we put something in here and colon that, right, that would still, or we would assume that this would result in a valid eject statement, but it doesn't do anything. It doesn't print that properly. Oh, interesting. Line 1, column 9 expects our brace in 2254. That's here. Okay. Now consume closing. Right. So yeah. Right. So what it says now is that it wants to consume the closing brace, but it sees this opening thing. That is because we do not eat and yeah, we do not eat and then properly consume the token. So what we have to do here now is we have to ask ourselves how many tokens we have to eat. So we can already pre-allocate a little array which stores the tokens. So let's say now, let's now compute after the peaking. We want to, by the way, this is minus peak n. If not peak token, do minus peak n. So peak n is the last token that's in there. Okay. So now we do for well, basically we can do well, we still need to declare int I as the index for this for loop, but what we can now do is we can go and I equals I think we started we started to, because we have now eaten these two tokens, we say I less than we started 0. We say I less than peak n. I plus plus And then what we do is for now, we simply consume the tokens that we encounter. So we say metac parser match. So we first grab the token type by peeking the token. So we say metac token t consume token, which is the metac peak token 1 actually, because we just picked one token ahead. We peek one token ahead, and we immediately consume that, and I think the match returns us a token, which we would append to an array actually, but for now we don't do that. For now we simply eat everything between the L brace and the R brace, so we simply match the consumed token type, and that's that. So now we will run this again, right? We run it, and then we will oh yeah, I have to put the self pointer in, of course. There we go. We simply eat that. So now we can do eject this, which we could already do before, but we can try and step through this. This shouldn't skip over. Oh, I was going to say this shouldn't skip over anything, but I guess I was wrong. Oh, so we have essentially peaked past the R brace, which means we gotta start I at 3, and then we say if I is less than peak and we do I plus plus. Okay, because we start no, that's not true. Well, no it is. No it is. Okay, yeah, let me first run this, and then once it works, we will work back from that and say why. Eject this. So this is something that should work. We have this. We say this. We jump over that. We match that, and we are done. Okay, now. Now we should be able to put something in here, and we should still be able to skip it. Okay. Let's now have a look. We injected 3 tokens. So we would assume peak n to be 6, which it is. That's very good. So we would assume this consuming to work. It does. Okay, now we will do the easy thing. I think we have a token buffer, and we can use this computation here essentially to compute how many tokens we need to consume. So we can easily say int consume, or rather, well, consume tokens will be pgan -3. That's what it will be. Consume tokens, and maybe like that. And then we can use that to pre-allocate an array, which I don't know if I have an arena in here. I would assume that I have a parser alloc. Let's see. If I have one, there should be a self alloc. Yes, I have a self allocator, which is a parser allocator. So what I can do is I can say arena array init which is an array of metac token t. The name is the it's the peak token buffer. Eject tokens. The allocator is a pointer to self allocator. That's what it is. I also declare an arena array. Well, the arena array essentially has to be well, I guess I can declare it here. The metac token to eject tokens. Okay, so let's do this. This at least compiled. Which is fine with me. And then we can say arena array and eject tokens comma this. So now we will actually array this should be working. Oh my god. Debugging with macros. It is it expects a different type. Is what I'm hearing. No, but why? I mean, consume tokens. And yeah, then we can do arena array ensure array ensure size, which is eject tokens, and the count is consume tokens. And right there we go. And which now means we have that. I think the match. I think it returns a pointer to a token, and we gotta deref that. I think that's the case. That is the case. Okay. Now we have an arena array which lives in the parser. It lives in the parser allocator. It living in the parser allocator means its lifetime is the same as the parser itself, and which also means that it has the same lifetime as the nodes in the parser. So that means we can simply. Oh no. We have to do two things here. So if we want to have proper location tracking for the tokens, then we need to have a location array as well. Okay, for now let's not worry about tracking the token locations here. Let's not worry about that. Let's simply add this, and we now only have to do one thing, which is we have to assign the eject tokens to the parse node, to the thing. I think we create that. Yeah, we create an eject statement node, which we do allocate it here, right? Yeah. We do allocate it, which means we set the result automatically to a pointer to that, but cast it correctly. So what we can do now is we can say, after doing this, we could say eject statement, eject tokens is a metac token buffer. So we can create this metac token buffer, and then assign that to the tokens. In order to be able to create a metac token buffer, tbuff. Well, we have a pointer to metac token buffer, which means this thing also needs to be stored in the allocator. So I think we have a metac We have a metac. We have a metac alloc t, and we have like allocator. I think we have an allocator. We have an allocator calloc call, which takes an allocator, a type, and an elem count. So this would be pointed to self allocator. The type would be a metac token buffer t. And the elem count is 1. And this gives us then a metac token buffer t. This gives us the pointer to the thing. Which we could simply assign, and then we can set the values of the token buffer t, which would then be this. The capacity of it is the same as the length. So we can say this will be, because we actually know exactly how long this is gonna be. This is consume tokens n. We also know exactly how long it's gonna be, which is the same, which is which is also consumed tokens n. And then we need the contents of it, or putter, which is a pointer to the thing. And the pointer to the thing is simply eject tokens. Which points to valid arena. Since we have an arena array, what we could also do, and this would probably be the smarter thing, we can allocate this arena array in the parse node itself. So we could go to the path tree, and instead of making it a token buffer, we could declare an arena array of eject tokens. And then everything would just work. And I think that's possible. I think that's possible, but I'm not sure. Okay. So now this would change to the eject statement. Eject tokens. Statement eject tokens. Basically, we would use this here. And then we would simply do an arena array add on that. And then we do not need this stuff here anymore, because we directly add it to the allocated node. So that's fine. So now all we have to do is we want to do a print for that. Let's say this. Well, I can simply skip to the printer here, and we already have a print token. So what we can do is we can do for. I want to do print new line. Print new line. There we go. Self. There we go. Just to make it really obvious where the stuff is. So we do for well, we have to do an int 0, I guess. Int 0 for I mean, I use this all the time, so whatever. Doesn't have to be C90 compatible for now, so let's do statement eject. And well, at least it does show me the macro, and now you have to know what you're doing. So, which is sort of nice, I guess. It says eject tokens count. Which, I mean, you just have to know what this macro does. And then we do print token. So I guess we want to do print intent. So and I guess we want to do an increase indent. Or maybe we don't. I'm actually not sure. But let's see. Print token ejected. Well. Statement ejected tokens I. That's that. And then I mean that's basically all we can do for now. Print token. Statement ejectee has no what? You have this for sure because I just put it in. Oh, it's eject tokens, not eject tokens. That's fine. Incompatible argument. What do you say it should be for print token? So I'm pretty. Oh, print. Yeah. Print token takes the token type. It doesn't take the actual token. So okay. Dot. Right. So now we at least print the token type. So now when we have an eject statement that goes like int that, we would print that somewhat properly and print token O. Print token does not like to do a token type, which it doesn't. Yeah, so this is talk keyword int. We do case keyword, and that would do print keyword self, and then keyword. So we would inject that for all the keywords, essentially. Or we could even do this and then a break, of course, break like that. And then we can inject this case by doing for each keyword token case. And now something really magical happens. We essentially now print all the keywords, all the keyword tokens. We still don't print any non-static tokens, but at least we will print all the keyword tokens, so we can say eject int something, and that should come out correctly. Okay. Yeah. We do not increase the indentation, which we definitely want to do. So let me quickly do an I'm quite sure there must be like a increase indent function. When we do a statement block, I am sure a statement block does. Oh, we do a plus plus indent level. We don't have a function call for that. Well, I mean, eh, right. Whatever. Then I guess we do a plus plus indent level. I mean, eject. There we go. Print indent. We do a plus plus. So indent level. There we go. There we do a print indent. Then we do indent level plus plus. And after we put the new line and print a new token, we say minus minus, and then we print the indent. Right, boom. And then we should now get a slightly nicer eject and car. We can even do int comma car, and that should give us a proper printout. Let me remove the breakpoint because we no longer need it. Or we do, let me guess, we don't print the comma in print token. Yes, I knew it. Alright. That's fine. We can simply add that talk comma, and we add it and it's here. So I think That would be what we would need to do in order to now do eject and comma void. So, boom. And we get this without the spacing because eject is simply a collection of tokens. We will also have to do talk dollar. Um, which isn't. You want the least common things to be right at the end. So there we go. There we go. You want the least common things to be right at the end, and the dollar will be even more uncommon than the bang. Dollar, which prints a dollar. So now we have this, and this should now be enough. We don't have a talk dollar. Interesting. I wonder. I wonder if we can go to the declaration. We cannot because that is in Lexer. We have a talk. This is not a binary token. A talk is a dollar is a unary token. It's a unary operator, and it may be that we don't parse that yet. Unary. We have a binary. We have a binary, right? First binary token, last binary token for each binary token. Talk dot 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 is a postfix thing, but we can define for each static token. I mean, technically, wait, we have a talk dollar. We have a talk. Oh, it's dollar. It's dollar with an A, not with an E. Dollar. Okay, now we can actually do an actual eject that you would do. Like eject case dollar my thing. The problem here is that we don't print identifiers, do we? But I think we have a print identifier in here. But I'm not sure of that. Let's see, print identifier. We have a print identifier. It takes a metac identifier pointer, but I think that's in the token, so maybe we can even do the case talk identifier. Where we then do print identifier. Print identifier self token token. I think it doesn't take a pointer, it takes the actual, oh. It only takes a token type, so we would do a print string. Identifier, comma, size of then -1 like that, and then we break, which we can do which isn't great, but whatever. It is what we can do for now. And we should do an eject this case dollar my expert colon do I don't know print dollar do I have hash? I don't have hash. Hash is even more uncommon than dollar, but we can certainly do hash. There we go. But for now we just do print $x, and then we close this, break, close this, and close this. Yeah, I'd say forgot a semicolon, but it doesn't matter because it doesn't get parsed yet. So this should work, I would think. It doesn't, which is interesting. It fails in printing. Print token. Well, what's the token type? Colon. Okay. Colon is a relatively thing that happens. Maybe a little bit more often than a comma. So yeah, that I guess would do it. If I run that now, we would have like an S eject that in case if it's case dollar something colon I don't know int x equals I don't know dollar index like that. So this would be injecting a case for something. This should. Yeah, we have case dollar identifier colon equals int identifier equals dollar identifier break. This is exactly what it should do. This is great. This is perfect. I am happy with this. So with that, we have done parsing for the eject statement. Great. Um,